proceed to the past papers, let's try to discuss the examples, more examples. So the points A and B have position vectors this respectively. Find in a vector form an equation of a straight line that passes through AB. Again, our equation is vector r is equal to A plus some number t or lambda times the vector p, where p is the direction. I'm gonna use this one to make it similar to the previous videos that we created. So again, what you need to ask yourself, is there a given point? And precisely, yes, actually there are two given points. Okay, so this is checked. Do we know the direction? So basically we do not know the direction yet, but can we find it? Yes. Actually we can get two directions. Either you get AB or you take BA. It does not matter, the answer will definitely be the same. So let's try to use AB. So the first step one is to find the direction. So we want AB, which is equal to vector OB minus vector OA, and your B is negative 2, 5, 0, minus your OA is 3, 1, negative 4. That one will give you negative 5, 4, and positive 4. And done. Therefore, the vector equation is R. You can use any point A. Let's say 3, negative 1, 4, plus some number lambda times the direction negative 5, 4, 4. Okay, so basically that's the answer. This one can be written as well using vector notation, unit vector notation, in the form of I, J, and K. So the vector R can be written as 3i minus 1j minus 1j plus 4k plus lambda times the direction negative 5i plus 4j plus 4k. So you have actually two ways of writing your answer, either in this form or in this form. So that's it for this question letter A. Next, letter B. You need to show that the point negative 12, 13, and 8 lies on the plane, lies on this line. So if negative 12, 13, and 8, negative 12, 13, and 8, okay, lies on a line, then there will be a lambda that will satisfy the equation. So this is the thinking process, because this one will give you the solution. Okay, let's look at that. So we want, I'm gonna use this one. So just for you to make it clear, again, this R is any vector x, y, z. In our case, that is your negative 12, 13, 8. And that is equal to your A, which is 3, negative 1, 4, plus some number lambda times negative 5, 4, 4. So basically here, you need to find, hold on, you need to find lambda that will satisfy this equation. Alright? And how you're gonna do that? I think I need to erase this one because I have no space. So let me just erase this one here for a while. Alright? So we need the lambda that will satisfy this, because you're gonna see it's negative 12. We're gonna get several equation that is negative 12 is equal to 3 minus 5 lambda. Okay? And then we also have 13 is equal to negative 1 plus 4 lambda. And then you have 8 is equal to 4 plus 4 lambda. So basically, if you would be able to get a lambda, okay, lambda, that satisfies these three equations, then the point negative 12, 13, 8 lies on a line. And if you solve this one, you will get actually the lambda, okay, which is equal to 3. You can try to solve it, and that's actually equal to 3. Therefore, you're going to say, since lambda is equal to 3, then the point negative 12, 13, 8 lies on the line. Okay? So that's how you're going to do it. Again, let's just summarize. If the question is about finding the equation or the vector equation of the line, you just need to find the direction and a given point. Then done. Okay? If, for example, you're trying to show that a point is on the line, then you need to plug it in here, and then you need to find the lambda. If there is a lambda that satisfies all the three equations, then that point is on the line. So let's try to look at the next question. A line is a vector equation given by r is equal to 3j plus k plus 4u is equal to this one. Alright? I think I need to have, okay, never mind. Show that this line intersects the x-axis. Okay? So, what do you mean by that? How will you show? The question there is that how are you going to show that it intersect with the x-axis? So you need to analyze that. If it intersects with the x-axis, it means that there is no y and there is no k. So the point is 1, 0, 0. So basically, this is the same thing as the previous example, that show or determine or prove that 1, 0, 0 lies in this line. Okay, so that's what we're going to do now. So basically, again, what we have said, r is equal to, I'll just use this one, 3, 1, 1 plus mu of 2, negative 1, negative 1. And then you need to show that the point 1, 0, 0 is on this line. Alright? And again, how shall we do that one? We need to show that there is a mu that will satisfy this equation. Okay? So, hold on. Not necessarily 100, because I am thinking if that is 00 here, the line could pass through this one, which is 100, or the line could pass through here, which is, let's say, 500, or the line could pass through here, let's say 300. Okay, so we don't know. Since we don't know, so then let's try to change this one, not one, because not definitely passing through one. Let's say a number C. Okay, but take a look. The one that we are pretty quite sure is that the y and the z are equal to 0. So now let's continue. So we have there uh, c 0 0. Remember, this is your xyz. Okay, is equal to 311 plus mu of 2 negative 1 negative 1. So what do we want to find out is there a mu that will satisfy the equation? So basically you have there now c is equal to 3 plus 2 mu. And then the other one is what? 0 is equal to 1 minus mu. And the other one is 0 is equal to 1 minus mu. Okay? Yes. All right. So now from here we can actually find the mu to be equal to 1. And here also the mu is equal to 1. So we need to check this one. We need to plug in here to find our point. So c now is equal to 3 plus 2 times 1. So the c is equal to 5. What does it mean? It means that the vector equation, that the vector will somehow pass through, okay, because this is 3D, we don't know whether it goes this way, it goes this way, it goes this way, but then because it's three-dimensional, okay, I mean it's so difficult to pinpoint the direction because you can rotate a three-dimensional. But what is certain is that it passed through that 5 0 comma 0. This is what's certain. It passes through that point. Alright? So that's for this video. The next one I'm going to discuss, or maybe I can now go into it. Alright, so I think I'll just discuss this one into the next video. Okay?